Here is a classic first taste of recursion. We are given a number n, say 5, and we want to print 1, 2, 3, 4, 5 in order. The catch is no loops allowed. A function is only allowed to call itself. So how do we make something that repeats out of a function that just keeps calling itself? The trick is to trust the function to solve a smaller version of the problem. To print 1 up to n, first ask the same function to print 1 up to n minus 1, and only after that finishes, print n. So the call for n waits, the call for n minus 1 waits, all the way down until n reaches 0. That is our base case, where we simply do nothing and return. Then the calls finish in reverse, printing 1, then 2, and so on up to n. It terminates because every call passes a smaller number, so we always march down towards 0. First, the base case. If n is 0, there is nothing to print, so we just return. Otherwise, before printing our own number, we call the function again with n minus 1, which prints every smaller number first. Only when that is done do we print n. That ordering is what gives us 1 up to n instead of n down to 1. Let's type it out in a live editor and watch the numbers appear in order. First, the base case. When n reaches 0, there is nothing left to print, so we stop and return. Then the recursive step. We print everything from 1 up to n minus 1 first. And only after the smaller numbers are done do we print n itself, which keeps the order rising. Now let's test it and hit run. There it is. 1, 2, 3, 4, 5, printed in order, and not a loop in sight. Try a bigger n and watch it still count up. The shape is simple. If n is 0, we return and print nothing. Otherwise, we first recurse on n minus 1 to print all the smaller numbers, and then we print n. Because the recursive call happens before the print, the small numbers land first. How costly is this? We make one call for each number from n down to 0, so that is order n calls in total. Each call prints one, so the time is order n. The space is also order n because all those pause calls stack up in memory until the base case is reached and they unwind. A few things to remember. First, the order matters a lot. Recursing before the print gives 1 up to n, while printing before recursing would give n down to 1. Second, never forget the base case at n equals 0, or the function calls itself forever. And third, because each call sits on the stack, a very large n can run you out of stack space.